Okay, so I'm sure you're all missing me by now, but behave and do what the sub tells you to do. All right, so we're going to go ahead and I'm going to continue with graphing rational functions. So the first thing we're going to do is I'm going to look and does anything cancel? So no, nothing cancels. Okay, my pen works now, so we don't.
Good morning, teachers and students. We're going to allow for, there was traffic out in the front of our building.
So I don't have anything to cross out. So the roots are going to come from the top. So my roots are going to equal 0 and -2. So I'm going to go ahead and put those on. I'm going to have 0 and -2. My vertical asymptotes come from the denominator. So my vertical asymptotes would be 3 and -6. So I'm going to go ahead and put those on my graph as well. So I'm going to put 1, 2, 3. And -6. So next I'm going to ask myself, is there tangency? So tangency is when you have a squared term on top, and I do have a squared term on top. So I'm going to have tangency at x equals 0 from this term right here. So that means at 0, I'm getting a bounce either on top or on bottom. And then I'm going to ask myself, do I have a squared term on bottom? I do have a squared term on bottom, so I'm going to have togetherness at x equal 3. So I'm either going to come up on both sides or go down on both sides. That's what the togetherness tells me.
Okay, thank you for your patience. We do think.
So next I want to look at the end behavior. And so the end behavior is I'm going to check the highest exponent on the top and on the bottom. And so I have x squared times x, which is going to give me x to the third. And on bottom, I have x squared times x, which gives me x to the third. These are tied, so I'm going to use the coefficient, which is y equals 1, which means I have no slant asymptote. Next, I'm going to have the y-intercept, which means I'm going to plug in 0. So I get 0 squared times 2 over -3 squared times 6. And so if you multiply all this together, it's still 0 times 2 divided by this number, and so the answer is going to be 0, 0. So my y-intercept is already on the graph. So next, I'm going to go ahead and put on the number line my vertical asymptotes and my roots. So I'm going to have -6, I'm going to have -2, I'm going to have 0, and 3. So then I have to test for positive and negative. So if I test -7, and so if I look at the graph, I don't have any points over here. So I'm going to go ahead and have to find a point over here anyway. So I'm going to find f of -7. So f of -7, if I put that in, f of -7, it's going to give me 49 squared times 9. So it's going to give me a huge number. So I know this is going to go way high. So let's just check for positive and negative. So if I do that, -7 squared is going to be a positive. -7 plus 2 is going to be a negative. -7 minus 3 is -10, but squared gives me a positive. And then -7 plus 6 is times a negative. So I get negative divided by negative is positive. So here is positive. So I know that the branch right here is going to look like this. Oh, I forgot to, oh goodness. I forgot to put the y equals 1 in. So when I draw this, it's going to go like this. Okay. So next, between -6 and 2, so I have to go ahead and test. So if I test between -6 and -2, so if I pick -3, so I have -3 squared is positive, -3 plus 2 is negative, -3 minus 3 is negative, but squared is positive, and then -3 plus 6 is positive, so this ends up being negative. So here I get negative. When I test between -2 and 0, if I test -1, so I get positive, and then I get positive. -1 minus 3 is going to give me negative, but squared is positive, and then -1 plus 6 is positive. So this gives me positive. So what do I know about what happens at 0? I know I get a bounce. So if I get a bounce, and if I know between -2 and 0 is positive, then the bounce has to go up. So 0 to 3 also has to be positive. And what do I know about what's happening at 3? I have togetherness at 3, which means over here has to be positive as well. So this is what it's going to look like. I have this branch. I know that this area right here has to be negative. So this has to go this way. I know that this area is positive and I'm getting a bounce. So I'm going to go here and back up. And then over here is positive. So I'm going to get this branch right here. So the next one I'm going to do is number 7. Okay, so for number 7, the first thing I'm going to have to do is I'm going to have to go ahead and factor. So I'm going to get x minus 4 and x plus 3. So if you look, none of the terms cancel. So I have no point discontinuity. My roots will come from the top. So my x is going to equal 4, -3, and 1. So I'm going to go ahead and put those on my graph. 1, 2, 3, 4. 1, 2, 3, and 1. The vertical asymptotes are going to come from the bottom. So that's plus or minus 2. So I'm going to go ahead and put those on. Plus 2 and minus 2. I do not have a squared term on top or on bottom, so I have no tangency. So since there's no tangency, that means that on my number line, I'm going to alternate positive and negative. So my end behavior, I'm going to have x to the 3rd on top. X squared times x is x to the 3rd. And then x times x is x squared. So I have no horizontal asymptote because it's top heavy, but it's top heavy by 1, which means I'm going to have to find the slant asymptote. And so to do that, you have to multiply everything together. And so I'm going to use this form right here times the x minus 1. So if I take x times each of these, and then the -1 times each of those, and I'm going to combine like terms then. So I'm going to get x to the 3rd minus x squared minus 12x minus x squared plus x plus 12. And so this whole thing is going to give me, I'm going to write it down here for you, x to the 3rd. When I combine this, I get minus 2x squared minus 12x plus 1 is minus 11x, and then plus 12. And then on bottom, if I multiply these two together, I get x squared minus 4. So this is not a candidate to do synthetic division. You're going to have to do long division for this one. So if I do that, I do x cubed minus 2x squared minus 11x plus 12 divided by x squared minus 4. So x to the third divided by x squared gives me x. So I'm going to multiply and get x to the third and then minus 4x, but I'm going to change the signs. So I have to bring down the 2x squared. So these cancel. This one we're not adding, I just brought it down. So this is still minus 2x squared. This one we are adding, so it's minus 7x plus 12. So then I'm going to take the minus 2x squared divided by x squared gives you minus 2. So for my slant asymptote, we don't care about anything after that. My slant asymptote ends up being x minus 2. So let's go ahead and put this on the graph. So we're going to start at negative 2, which is here, and then you go up 1 over 1. So these, my slant asymptote goes this way and this way. So next I need to find my y-intercept, which means I'm going to plug zeros in. So I'm going to get negative 4 times 3 times negative 1 over 2 times negative 2, which is going to give me 12 divided by negative 4, which is negative 3. So my y-intercept is 0 and negative 3. So I'm going to put that point right there. So I'm going to go ahead and on my number line, I'm going to have negative 3, negative 2, 1, 2, and 4. So let's test negative 4. So if I put negative 4, I'm going to get a negative times a negative times a negative all over a negative and a negative. So this gives me a negative divided by a positive, which means it's negative. So if I start negative, each one of these is going to alternate now because I have no tangency and no togetherness. So this is positive, this is negative, this is positive, this is negative, and this is positive. So that tells me that from negative 3, which is right here, all of this has to be negative. So that tells me that this is going down. From negative 3 to negative 2 is positive. So this is going up. Next, I'm going to, here's my point. And so we said from negative 2 to 1, that was all negative. So this is going to go this way, and this is going to go this way. And then from 2 to 4 is negative, so this goes down, and this goes this way. So that's what the graph would look like. I'm going to do one more, which is number 8. Maybe. Okay, so for number 8, the first thing I have to do is I need to factor on top. So I'm looking, and none of my terms cancel, so I have no point discontinuity. My roots are going to come from the top. So I'm going to have 1 and -4. So I'm going to put those on. 1, -4. My vertical asymptote will come from the denominator. So x equals -2. So I'm going to go ahead and put that in. Now, I'm going to check for togetherness or tangency. Do I have a squared term on top? I do not, so I do not have any tangency, but I do have a squared term on bottom, so I'm going to have togetherness. So that means it's either going to look like this or like this at -2. So next I'm going to check my end behavior. So I'm going to have on top I have 3x squared, and on bottom I just have x squared. These are tied, so I'm going to use the leading coefficient, which is going to be y equals 3. So I'm going to put that on the graph before I forget. So this goes here. So that means I have no slant asymptote this time. And so my y-intercept, I'm going to go ahead and plug in 0, which is going to give me 3 times -1 times 4 over 2 squared. So on top I have -12 divided by 4, so I get 0, -3. So I'm going to go ahead and put that point on. 0, -3 right there. So on the number line, I'm going to have -4, and then I'm going to have -2 and 1. So I want to check -4. So if I put -4 in, I would have a positive times a negative. Well, the 3 is positive, so that's why it's positive. And then -4 minus 1 gives me negative. And then, oh wait, we need to test 5. Oh, goodness. Y'all, I was testing 4, and that's my point, so I can't test that. I have to test on this side of it, so I'm going to test -5. So the 3 is positive. The 5 is going to give me negative. The -5 is going to give me another negative. And then on bottom, I get -3. I get a negative squared, which gives me positive. So this ends up positive. So I have a positive there. So next, at the -2, I get togetherness. So I need to check whether I have negative togetherness or positive togetherness. So if this is positive, if it goes up, then this side would go up. So let's check. So in between, so f of -3, I would start positive. The -3 would give me negative, and then positive. And on bottom, I would get negative squared, which would be positive. So this is negative. So if this is negative, this also has to be negative because they're together. And so then this would have to go back to positive because it would alternate. So on this side, this is going to be positive. I have to check and see whether it's going to cross my asymptote. So my asymptote equals 3. So what I'm going to do is I'm going to multiply this all together. So 3x times x gives me 3x squared. 3x times 4 gives me 12x. Minus 3x minus 12. And on bottom, if I multiply this, I get x squared plus 4x plus 4. So I'm going to get 3x squared plus 9x minus 12 So what I'm going to do is I'm going to take this whole function right here and I'm going to set it equal to 3 because y equals 3 right here. And so I'm going to do that. Okay, I'm just getting some blank area to write. So I end up having 3x squared plus 9x minus 12 over x squared plus 4x plus 4, and I'm going to set it equal to 3. I want to see if it's going to cross the horizontal asymptote. So what I have to do really is I'm going to cross multiply. So I get 3x squared plus 9x minus 12, because that's times 1, and I'm going to multiply this times 3. 3x squared plus 12x plus 12. So the 3x squareds cancel out. I'm going to subtract 9x, and then I'm going to subtract the 12. So I get 3x equals negative 24. So when I divide by 3, so what that tells me is that the function is going to cross the horizontal asymptote at x equal 8. So let's find x equal 8 on the horizontal asymptote. So on the horizontal asymptote, here's x equals 8. So this tells me that this area is all positive, and I'm going to cross the asymptote right here. So this is going to go above the asymptote. Between negative 4 and negative 2 is negative, so this is going this way. I know it's not going to cross on this side because we just found out it only crosses in one place. So this side is also negative. This is together. So this is going this way. And then it stays negative up to here, and then it turns positive, but it doesn't cross.